Hi, welcome to lecture 8. Here we will see the internal ROM of 8051. 8051 follow Harvard architecture. So data memory RAM and the program code memory ROM are entirely different physical memories. That is, two memories are kept in different location or they are physically different inside the chip. Here in block diagram, we can see that clearly. This is the RAM and this is the ROM. So both are different physical units. So this is the internal ROM. Actually, the internal ROM is 4K, 4 kilobyte. So internal ROM, internal ROM of 8051 is represented as 4K into 8. Actually, this is a memory representation. If you don't understand this representation, you can watch my memory video. So 4K into 8 means it has 4K locations and each location can carry 8 bit. So 4K location means number of locations equal to 4 into 1K is 1024, 1 kilobyte equal to 4096 locations. So we have 4096 location. Actually, ROM is used to store our program codes permanently. So if we have 4096 locations, how many address lines are required to address these many locations? We will see. Number of address lines. This is the formula log 2 number of locations. Log 2 n is a formula where n is the number of location. That is equal to log 2. How many locations are there? 4096. That's equal to 12. So we need 12 lines or 12 wires or 12 bits for address. So what will be the address range? It's so simple, right? 12.0 to 12.1 in binary. So address range, we will see the address range. Address range, first of all, I will write in binary. This is the binary form. 12 zeros. To 12 ones. This is the address range in binary. And hexadecimal, this 0 is represented by 0, this 4 bit, again 0, this 4 bit, again 0. So 000H to this 1111 means 41 means F or 15. So F, then for this F, for this 4 bit F. So this is the address range 000H to FFFH. This can be in a textbook, which is often written as 0000H. Actually, putting in the MSB side 0 will not make any difference. This address is same as this address. To 0FFFH. Actually, now if we expand this address, we will get 16 bit because for this 0 also we will get 4 zeros, right? And this 0, 4 zeros. Actually, it is the address. The internal ROM address is also written in 16-bit format, because if our 4K memory is not enough, we can connect an external memory with 8051, which is 64 kilobyte long. For a 64K memory, I have already shown you, we want 16 address lines. So actually, that's why it is given in the 16-bit format. But to address the internal RAM, which is 4K, we only need 12 wires. Keep that in mind. Okay, so this is the address range of the memory. So in our internal ROM of 8051, we have 4096 locations, which is equivalent to 4K locations, and each location can store 8-bit of data. So this is the internal ROM organization. Actually, ROM is a plain memory with 4K locations. So ROM is used to show program code. And our program counter, which is a 16-bit register, is generally the pointer to ROM location. Okay.